Hello! I lost my thought for a minute in the first minute. Okay, 5.3, solving a quadratic equations by factoring. And I kind of actually like to factor. Kids usually don't, but I don't mind it. Yeah, all kinds of things, determining from factoring. Okay, intercept form. This lesson's going to be really, I think, short and quick. We have been working with standard form for our linear or quadratic equations. So here's your standard form, y equals x squared plus bx plus c. It looks familiar, you've seen it, but now we got to introduce another form. Just like you have three forms of a linear equation, you also have different forms of quadratics. Y equals a times the quantity x minus p times the quantity x minus q, where p and q represent the x-intercepts to the corresponding equation. FOIL is on here mostly because we also need to know that we are going to be foiling and doing the reverse FOIL, which is basically factoring. Okay, so a times x minus p times x minus q. Okay, we're not going to worry about the coefficient at this time. Okay, so a minus, you're going to do your, hold on, let's go back a page here so you can kind of see here. You got your x minus p and your x minus q. P and q are the x-intercepts. Uh-oh, wrong way. These are the Gibbons roots. So this is your x-intercept and this is your other x-intercept. I want to do x just to make us look like we're on the same page as we were on before. All right, so you're going to have x minus the 2. And then you have x minus the 4. Okay, now it says write an equation. Well, that is basically an equation right there. We need to be prepared because probably we're not always going to want that in this form. What if we want it in the other form? Well, that's where FOIL comes in. So x times x is x squared. X times negative 4 is negative 4x. Negative 2 times, oh, I think I'm supposed to, negative 2x, that's your outer, and this is your inner, and then we have last as well, so we have plus 8. So really, if you can simplify this, you have x squared minus 6x plus 8. So your form, your x-intercept form, and then your standard form. Yeah, your intercept form. Let's try it one more time. This is a little different here because you have now x minus negative 4. And then you also have x minus 7. Be aware when you have minus negative, that's the same as plus. So I would not accept this as your, if you were allowed to leave it in the intercept form, I would not allow you to leave a minus negative. You need to simplify that out. So that's x plus 4, x minus 7. And once again, how do you get from here to the other form? Oh, you FOIL. You just do the math. So you have x squared. Then I do my outer terms, negative 7x. Inner terms, plus 4x. Last terms, negative 28. And also, you need to simplify this. Y equals x squared minus 3x minus 28. All right, here we got x minus, or negative 6 and negative 8. So I'm going to go ahead and write it out, x minus negative 6. I'm just going to write down plus 6. I think you can handle that. All right, x minus negative 8 is actually plus 8. FOIL it if you need to. I'm just going to keep showing you FOIL for a little while. We have x squared, and then you do your outer terms. You have 8x. You do your inner terms. You have 6x. And then you have 6 times 8 is 48. So now x squared plus 14x plus 48. That's what y equals. What are you going to do here? X minus 3. And then you're also going to have x minus 3. Huh. X squared minus 3x plus 9. That's the FOIL. We get x squared minus 6x plus 9. Basically, it's like saying you have two roots One of them is 3, the other one is 3. We don't have to write it out twice. Okay, but you are going to have to write this out twice, so you FOIL it back. Otherwise, if you just have, sorry if I can't, try to cover it up with my hand if you can't see that part. If you just have this much, what's that? That's linear. All right, example number 2, write an equation with the given roots. Oh, and now we're going to write it with the form ax squared plus bx plus c. It's required, where a, b, and c are integers. If they're integers, they cannot be fractions, they cannot be decimals. It just so happened on this previous page, nothing turned out to be a fraction or a decimal. All right, so here we go. We have x minus negative 2/3, so I put plus 2/3. And I have x minus 6. And I have to rewrite this, all right, in the form ax squared plus bx plus c. So I have y equals FOIL, I have x squared minus 6x plus 2/3 x. What is 6 times 2/3? Let me do that off to the side. 6 times 2/3, take the top times the top, the bottom times the bottom. If you want, the bottom would be 1. That's 4. So I'm putting a 4 right there. Ooh, you know what I'm going to do even before? I think technically I should probably add this to this, but you know what I think we're going to do? Let's take the entire equation. I think this will be easier for you. Let's take the whole thing times 3. Get rid of that fraction, because remember, we have to have the value not be integer. So this is 3 times everything. Y equals 3x squared minus 18x plus 2x minus 4. So y equals 3x squared, combine like terms, negative 16x minus 4. And we have a, b, and c are going to all be integers. Example number 3. Same idea right here. X minus negative 3/4 would be plus 3/4. And then I have x minus 5. Write a quadratic equation. Those are the roots. Let's go ahead and try it one more time. We've got x squared. We have negative 5x. We have 3/4 x. And then I have negative 15/4. Once again, I can do this crazy thing right here, combine those together, but I think I'm just going to wait. I'm going to take everything now times the denominator, and that'll allow me to not have to work with the fractions anymore. So I'm going to take it times 4. So y equals 4x squared minus 20x plus 3x minus 15. You're like, how did I get those numbers? Well, what's 4 times 3/4? Well, you can take 12 over 4, or I cancel sometimes, and then I get the 3. If you take 4 times 15 over 4, the 4's cancel, you're left with 15. All right, 4x squared minus 17x minus 15. All right, feeling good about that. Let's move on to the next example. There's not another example? Well, that's lovely.